Right. Now, first and foremost, let's start with 2004. Right. 2004 MCQs. So, first things first, as I said, according to the plan, we'll do from the calculation. Right. From the calculation. So, as I said, there will be lots of units which is there in between those areas. So, we have around unit 3, unit 4, unit 5 and all. Those all said I have said in the first video. Right. So, let's go on with the MCQ part. Okay. So, in 2004, the third question, right? The third question, the third MCQ, MCQ number 3, it has actually come from the gases actually. It has come actually from gases, right? From the unit gases. So you have unit 4. But let's see the question. Oxygen gas, auto gas in a glass vessel is partially converted to O3 by means of an electrical discharge according to the following equation, right? Okay, now you see, now there's a vessel, right? Now this is going to be your rods here, and here you have your auto gas, right? Auto gas, right? And there's an auto gas here. You're giving electrical sparks, right? The reason for giving electrical sparks in this case is to give the energy for the bond break, right? To break the bonds, you have to give a lot of energy. So the best part is to give electrical sparks in this case, right? In a closed system. So according to the following equation, so they have given the equation. So we have 3 O2 gas. It converts completely to 2 O3 gas. So you know what's O3? O3 is actually the ozone, right? When 30% of O2 gas is converted to O3, the reduction in the pressure inside the vessel, right? Okay. Now, initially there was O2 gas. Initially, there was O2 gas. Let's say there was a pressure P naught. Let's say there was a pressure P naught. During the electrical discharge, some amount of O2 has been converted to O3. They have given in the question itself, around 30%. So, let's say if there was X mole, let's say there was X mole, okay, there was X mole. And see here in the question itself, they didn't talk anything about the volume change nor the temperature change, right? They didn't speak anything about the volume change or the temperature change. So you have to consider in this MCQ that the temperature and the volume is actually the constant case, right? A very simple MCQ. So once you write PV is equal nRT, see here you have temperature. The absolute temperature is actually constant. Volume is also constant. So you know R, the universal gas constant, is actually a constant itself, right? So what you can do is you can directly take a proportionate here. So you can say pressure is directly proportional to the number of moles present in the system. Okay. Now my initial system is actually P naught. So initially I had X moles, right? I had X moles. Initially I had X moles. Now they said 30% of the oxygen is converted to ozone, right? So let's say now the initial moles, right? I have P naught here. So we have initial mole then you have the remaining mole, right? Remaining mole, right? Now we have the remaining mole. Now see, initially you had x moles, so nothing was there. After reacting, they said around 0.3, around 0.3. So now see here, if 0.3 x moles reacted, if 0.3 x moles was reacted, then how many moles should be there? So how many moles should be there? According to this stoichiometric ratio, I'll say directly this will be 0.2 here. How? So let's say NO2 is there and you have NO3. What's your stoichiometric ratio? For me, oxygen is actually 3 here. For this, you have 2. Initially, you had 0.3 reacting. Initially, you had 0.3 reacting. So you have 0.3 moles of O2 with NO3 here. So you have 3/2 ratio. If you finally cancel this up, the number of moles formed for the ozone is actually going to be, if you cancel these two, you will get 0.1, right? If you cancel these two, you get 0.1 moles. So you get 0.2 moles that is actually formed here. So you have 0.2 x moles, 0.2 x moles here, right? You have here x and here you also you have x. You have 0.2 x moles. So what will happen? You will get 0.7x, right? 0.7x. Here you will get 0.2 x moles. So the total number of moles is going to be Nt, which is equal to 0.7 plus 0.2, right? 0.7 x plus 0.2 x, so around 0.9x, right? Now see here, initially you had x, now it has become point, it has been, the number of moles has been decreased to 0.9 x moles, right? The number of moles has been decreased by 0.1, right? So they have asking the reduction percentage. So the change in pressure in the system, right? So you have to write the change in pressure of the system, right? Of the system is equal to the final minus initial pressure over the initial pressure that you had in system into 100%. But see here, instead of the pressure, I can write in terms of moles, no? Understood? I can write this pressure in terms of moles. So I took the final answer in moles also. You can do with the pressure also, no harm. You can take the number of moles and if you put here P dash, which is directly proportional to 0.9 x moles, you can get how many moles of P dash has been changed. So I can write in terms of number of moles. You can do with the pressure also, no harm, right? All the answers will be the same. So you guys can ask, you're going to get the answer in negative, right? Why? They have already said in the question that is actually reduced. So what I can do is, I can directly write like this. So initially I had x moles. I got the change around I got the final moles around 0.9. But initially I had x moles. Then for 100%. So simple maths. 1 minus 0.9, 0.1. Already 1 is here. So x and x will get cancelled here. Right? 0.1 into 100, you are going to get 10%. Right? You are going to get 10%. Right? So what is the answer we have? 10%. So actually it is going to be the second answer. Clear? They have asked with the gases, right? They have asked with the gases. So if you know this proportionately, you can directly get the answer just by the substitution itself. Just as a short method, initially you had x mole, final mole, just taking the final number of moles here itself, you can say 10% has been changed because 0.1 is there now. Initially you had x, you have 0.1, 0.9x, so 0.1 is going to be your change. So how much? Into 100%. So 10% is going to be your actual change in the pressure. So how much it is reduced? By 10%. So that is going to be your second answer. Now let's go on with the fifth part in the next video.